In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are family, a partner. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss downstream refining production facilities, my lecture number 3. Light FCC, gasoline, extracted sweetening, heavy hydrocarbon sweetening, hydrogenation, hydrofinisher, Hydrotreater, Plymerization, lecture number 3. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose the knot from my tongue that they may understand my sins. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and a true understanding. Okay, now I'm going to run a complete trail on my lecture number 3. Please send me your input, your feedback, comments, whatsoever. I have provided my email address and WhatsApp number on my last slide of my presentation. Thank you very much. Okay, we have a plan to discuss in downstream refining production facilities, sweetening light hydrocarbon Merox, sweetening liquid petroleum LPG Merox units, liquid petroleum hydrogenations, heavy hydrocarbon hydrofinishers, light cyclic oil hydrotreater, liquid petroleum gas LPG polymerizations. These all section one by one we will discuss next couple of years. So probably you will find a lot of interesting outcomes and interesting theories about these, and we will also run some models, artificial model we have developed to understand how each units are performing. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. So plan to deliver more than 300 lectures in the next couple of years. Okay, refining of production facilities, light FCC, gasoline extraction and sweetening, theoretical descriptions of the sweetening process, lecture number 3. Okay, key takeaway points from lecture number 3, downstream refining production facilities. We will discuss process descriptions, chemical reaction, and vital are 5 variables. Okay, theoretical description of the sweetening process. Okay, what we're going to discuss, mercaptans, disulfides, a sulfur content, contains injections, dilute sodium hydroxides. Okay, the manic units, Merox units, and all sweetening type units, the mercaptans are converted directly to sulfides, which remain in the product. There is no reduction in the total sulfur content because the vapor pressure of the disulfides are so low relative to those of the mercaptan, their presence is much less objectionable. The Merox process relies on small continuous injections of an appropriate strength alkali solution rather than gross intermediate alkali saturations of the catalyst bed as used in the conventional Merox fixed bed sweetening unit. This continues a small injection of alkali such as dilute sodium hydroxide solution 2 to 5 ppm is held to a minimum but enough to provide a needed alkalinity. In this way, mercaptans are oxidized to disulfides and do not enter into the peroxidation reactions in case of insufficient alkalinity. For Merox systems, the pretreatment is rarely required. The need for the pretreatment depends on the feed characteristics, treated product specification, and end use. For charged stocks such as light gasoline where more than a low ppm levels of the hydrogen sulfides are present, the charged stock is passed through a caustic gold scrubber to ensure essentially complete removal of hydrogen sulfide H2S. Hydrogen sulfide does not poison the catalyst, but it competes with mercaptans for the available oxygens. Post-treatment is not required on the Merox sweetening systems. Okay, from my next slide, I'm going to discuss the chemical reaction of a sweetening unit. Okay, now I'm going to discuss chemical reactions. The name Merox originates from the function of process itself, namely the conversion of mercaptans by oxidizations. Okay, this is my mercaptan and then oxidation process, and it converts into disulfides. The word mercaptans is a descriptive name applied over 140 years ago to organic compounds with the sulfohydryl function, that is SH, and derived from the Latin mercurium captains due to their mercury seizing properties. Today, most of the research literature assigns the word ethyl for this function group. In the common system used by the petroleum industry, mercaptans are named after their analogous alcoholic counterparts. The CH3SH by the common system is methyl mercaptans, just as one would name as alcoholic having the formula CH3OH methyl alcoholic. The stick formula name is methanol ethyl. Likewise, N-butyl mercaptans becomes 1-butane ethyl. 1-butyl mercaptans becomes a 2-methyl, a 2-propoethyl. The aryl mercaptans are commonly used in thiophenols, while in the form system as used by the chemical abstracts, these compounds are benzene ethyls, toluene ethyl, etc. The description uses the common mercaptans terminology as practiced in petroleum industry. Okay, from the next slide, we will discuss a sweetening and their further extraction process and then their key 5 parameters. Okay, what is the treatment process? Basically, it comprises of 3 segments: extractions, reactions, caustic, regenerations. Light gasoline treatment process, the synthesis of extract and convert mercaptans in disulfides which remain in the product. Following are the key process to treat sour gasoline product. Sometimes a treatment is required based on the feed characteristics if H2S hydrogen sulfides is present in low ppm level inside the light hydrocarbon. This must be passed through the caustic or scrubber to ensure complete removal of hydrogen sulfide from the feed. This does not poison the catalyst, but it competes with mercaptan in the presence of available oxygen. Okay, furthermore, the Merox process in all its application is based on the ability of an organometallic catalyst to accelerate the oxidization of mercaptan to disulfide at or near ambient temperature and pressures. In the sweetening reactions, a hydrocarbon containing mercaptans is brought in contact with the caustic soda solution, air, and catalyst is convert the mercaptan to oil-soluble disulfide without changing the sulfur content of the hydrocarbons. Okay, if you can see reaction here, so over here it demonstrates here. First here, this is my RSH. So it contains where the organ compound with sulfur hydro functions, and this is my oxygen oxidizations, and then it is waters and remain here oil soluble disulfides. Okay. R is a hydrocarbon which may be state or branched or cyclic chain. The chains may be saturated or unsaturated. In most petroleum fractions, there will be a mixture of mercaptans to the extent that the all chains might have 1, 2, 3 or 10 or more carbon atoms in chain. When the reactions occurs, two different mercaptans might enter the reaction. This is indicated over here, if you can see R and R dash here and R here. Okay, this reaction occurs spontaneous but at a very low rate whenever any sour mercaptans bearing distill is exposed to atmospheric oxygen. Okay, so from the next slide we will further discuss on extraction process. Okay, what is extraction? Extraction process is applied to both gases and liquid hydrocarbon streams. The degree of completeness of mercaptan extractions depends upon the solubility of mercaptan in an alkaline solution. That is in turn depends primarily upon, as we have listed here, first molecular weight of the mercaptan, degree of branching of mercaptan molecules, caustic soda concentrations, temperature of the systems. Okay, as the molecular weight of the mercaptan increases, solubility in the alkaline solution decreases, and a chain of branching increases or solubility decreases. Okay. Okay. If you see my first equations, that is RSH demonstrate oil phase and sodium hydroxide aqueous phase. Okay. So when they reacted, so we have water H2O and aqueous phase sodium SR. Okay. The ability of Merox process is completely regenerate. Caustic for depends on, as we have seen the equations, NSR or sodium SR, that is mercaptan, plus quarter oxygen and half water H2O. When reacted, it turn into sodium hydroxides and RSSR disulfides. Okay. Okay, of course, nothing can be done to control either the amount of molecules weight of the mercaptans present, as this is the function of the crude source and distal cut of the feed. However, for mercaptans of the same molecules of weight, primarily mercaptans will be almost completely extracted, secondary mercaptan will be less completely extracted, and tertiary mercaptan will be least completely extracted. This is true function of the feedstock. Okay, I will further discuss on my next slide the primary mercaptan, secondary and tertiary mercaptan. Okay, as discussed in my earlier slide, of course nothing can be done to control either the amount of molecules weight of the mercaptan present, as this is a function of the crude source and distillation out of the feed. However, for the mercaptan of the same molecule weight, primary mercaptan will be most completely extracted, secondary mercaptan will be less, and tertiary are least. Is a function of the feedstock. If you can see here, my primary mercaptan here, and it contains a 1R and 2R and tertiary a 3R. R is a hydrocarbon chain, as we have discussed in my earlier slide, state or branch chains. Because of these factors, mercaptan extraction is used mainly for a low boiling range petroleum fractions such as C3, C4, and a light gasoline, which only contain a low molecular weight mercaptan and where the reduction in the sulfur content is needed or desired. Okay. If hydrogen sulfide is present in a low ppm level inside the light hydrocarbon, this must be passed through the caustic oxide scrubber to ensure complete removal of hydrogen sulfide from the feedstock. Okay, now we're going to discuss 5 key operating variables for a treatment process. Okay, we're going to discuss the major Merox process variable and their effect on performance. Specific emphasis will be placed on the identifying the optimum operating conditions. First catalyst, oxygen, alkalinity, contact and heat. First catalyst, concentrations. For the Merox unit, the catalyst concentration is not a variable. The charcoal should be impregnated with a 1.4 kg of UP Merox reagent per cubic meter of the charcoal, a 0.087 pounds per cubic feet. Over the course of a run, catalyst activity will be gradually decline. When deactivation reaches an intolerable level, reactivation with additional catalyst should be conducted. Okay, from the next slide, we'll discuss oxygen injection. Okay, now we are going to discuss oxygen injection. Oxygen is supplied to all versions of Merox process in the form of compressed atmospheric air. The stoichiometric or theoretical amount of oxygen necessary is a 0.25 kg per kilogram of mercaptan sulfur or 0.25 pounds oxygen per pounds of mercaptan sulfur at standard condition of temperature and pressure. 1 cubic meter atmospheric air contains about 0.4 kg of the oxygen. 1 cubic foot of the contains about 0.018 pounds of oxygen. Therefore, about 0.88 standard meter cube of the air needed for each kilogram of mercaptan sulfur are to be oxidized. Okay, it is of course necessary to have at least a slight excess of oxygen present, but it is always recommended to keep the excess to a minimum. The amount of excess air injection necessary is highly dependent upon the individual feedstock, but normally range between 1.2 to 2 times the theoretical requirement. Thus, a good initial injection rate 1.5 a time theoretical may be calculated as we have given the formula. Okay, the parameter, the air injection rate, SCFH, K constant factor, feed rate, specific gravity, and mercaptan sulfur, that is RSH. For the manic and other fixed bed, the air injected must be completely dissolved in the hydrocarbon, otherwise a separate air phase will exist within the fixed bed and can eventually lead to channeling. The most important factor of the solubility is a pressure on the system, thus the sufficient pressure is to dissolve the required must be maintained at all times. Okay, pressure is in fact a secondary variable since pressure is directly proportional to the solubility of air in the hydrocarbon. Okay, from the next slide we will discuss alkalinity. Okay, alkalinity. Alkalinity is needed to selectively drive the mercaptan oxidation reactions. Alkalinity is provided by aqueous sodium hydroxides or caustic solution. The mercaptan encountered in the feed to Merox units are typical to rarely oxidize that the very little alkalinity is required. Only a sufficient caustic be injected to maintain the drain effluent from 9 to 12 pH, about 2 to 10 of 8 ppm of sodium hydroxide caustic concentration, 3 to 5 bomb to 2 to 3 weight percent is normally sufficient. However, one another factor must be considered. Thiophenol, when present with olefins as in the catalytically cracked gasoline, can be easily oxidized to a thioethers, hydroxides, gum precursors caustic by transferring the thiophenols to the aqueous phase will prevent this peroxidations. Thus, the sufficient quantity of the caustic must be injected to tie up all of the thiophenol present in the feed until it can be converted to disulfide. Okay. As we have seen here, experience has shown that this quantity of caustic injection need not necessarily be stoichiometric amount. A single molecule of caustic will arrest hydroperoxides for many molecules of the thiophenol. The tendency to form a gum via this mechanism may be monitored with the peroxide number test. A sufficient quantity of the caustic injection should be maintained to yield a peroxide number of 0.3 or less. Of course, any acids present in the feed leads to caustic neutralizations, or caustic is neutralized, it must be replaced in order to maintain acceptable operation. Okay, from my next slide, we will discuss a contact. Okay, now we're going to discuss contact. Contact may be defined as the intimacy of mixing of the reactants. Contact is accomplished by one of the several means. Contact can be characterized by duration of mixing time, by volumetric ratio of the reactants, or by differential pressure, which implies degree of dispersion with fixed flow restriction. The differential pressure is directly related to the linear velocity. To that, velocity is often taken to be a process variable. The primary source of contact in a fixed bed unit is charcoal bed itself. The porous structure of the charcoal provides the vast interfacial surface area necessary for contact between the hydrocarbon, caustic, and catalyst. The variable used to characterize a contact is residence time in the charcoal bed. The residence time is often expressed in terms of volume of the feed per hour upper volume of catalyst bed. The commonly term for this is a liquid hourly space velocity, also known as LHSV, liquid hourly space velocity. As residence time increases, LHSV decreases, Mercaptan conversion increases. As the catalyst bed accumulates running time, the charcoal pores tend to plug and becomes blinded by extremely heavy hydrocarbon molecules. This reduces contact and is largely cause of the fixed bed deactivation. Fixed bed deactivation results in high mercaptan content in the product, which will not respond to corrective actions. As a result, either reduced a feed rate for lower HSV or catalyst bed reactivation will be required. Okay. From the next slide, I'm going to discuss a heat temperature. Okay, this is my last slide. Fifth key parameter for the treatment unit, heat. Okay. The Merox fixed bed sweetening is favored by high temperature. Increasing the hydrocarbon feed temperature increases the rate of mercaptan conversions. However, increasing the temperature will also enhance other oxidization reaction, which may be undesirable because of color deteriorations, gum precursors of formations, and a premature catalyst bed deactivation. Therefore, the feed temperature should be kept as low as possible while still maintaining desired temperature of the mercaptan conversion. Normally, this is range 38 to 50 degrees Celsius. Temperature is also limited by storage considerations such as the flash point or vapor losses. Feed temperature is excessive to 60 degrees Celsius for a long period should be avoided because of metallurgical considerations. Thank you very much for your precious time. From my next slide, I'm going to conclude and then we will demonstrate what we have planned to demonstrate in my next lecture. Okay, conclusion. Today we have discussed a process description, chemical reaction, and vital key parameters. Okay. Next topic, we are going to discuss material and heat balance. These are a few references. Qatar Petroleum, Oil and Gas Development Corporation Limited, Pakistan, OGDC, World Energy Outlook, US Geological Survey, US Department of Energy, Schellenberger's Oil Field Glossary, International Energy Agency, Wikipedia, Oklahoma State, State Oil Facts and Sheets, No.6 Standard, The Story of Oil in Pennsylvania, a look at gas, Encyclopedia, Natural Gas from the Wellhead to One Bit. Together, everyone achieve more. Please do not hesitate. Send me your feedback and comments t.masood.dr@bath.edu. I have also provided my WhatsApp number. Please send me your email or WhatsApp. Thank you very much for your precious time.